So today's lesson, 1-7, day 2, we're still focusing on rewriting equations and formulas, and we're going to even solve some literal equations for given variables. So a couple of formulas that we did need to do because we're going to do some word problems. I gave you distance formula again. D equals RT. D is our distance, R is our rate, T is our time. Temperature, I don't think we've used this one yet before, but to convert from Celsius to Fahrenheit, we have this formula. C equals 5/9 times the Fahrenheit degrees minus 32. And then simple interest is our last one we're going to use today. I stands for interest, P for our principal, or I'm going to let's add a little piece there. Principal, it's the principal amount, but it's the money, so you could put a $sign, money deposited. That'll help, especially when we get to our word problems, because they're not going to tell you the principal is this. They're just going to say you deposited $300 or you deposited $2,000. Okay, so principal stands for the money deposited. Our R stands for our annual interest rate. They will give it to you as a percentage. You have to convert it to a decimal. So I think you guys told me, how do we convert a decimal to a percent to a decimal? What do we have to divide by? 100. Excellent. Okay, so we'll do that as well. And then T is our time, and I want to add something in here too, and I should have done it in the type, but I did not. Time for interest, because we're talking annual, it's in years, okay? So if it was a year, it'd be a year. What if I said 6 months? How many years is that? A half a year. 1/2 or 0.5 would be fine. So make sure your time is in years. If it's not, we have to make sure we convert it to years, okay? So let's do the first one. It says solve the temperature formula for F. So we're going to take this temperature formula. C equals 5/9 times F minus 32. And we're solving for F. This is what we did the other day. That means I have to isolate F, okay? Right now it's being multiplied by 5/9 and being subtracted by 32, by 32. Notice there are parentheses around this F minus 32. I can't touch that minus 32 yet. I have to get rid of the 5/9 first. Now, some of you guys may want to distribute that first, and that's fine. Others, I would prefer if we just got rid of multiplying by 5/9 first, okay? But if you prefer to distribute, you can absolutely do that. I'm going to rid this by multiplying that fraction by its reciprocal. Well, what's the reciprocal? The flipped version of 5/9. Yep, 9/5. And I have to do it to the other side of my equal sign as well. Remember, keeping organized, my equal signs are going to stay lined up. 9/5 times 5/9 cancels out, okay? And I'm left with F minus 32. Notice the parentheses dropped off because there's nothing else besides F minus 32. And the best I can write my 9/5 times C is just 9/5 C. The last thing, what are we going to do to get F by itself? Add 32. Now 32 does not have a C attached, correct? So it's not a like term. So the best we can write it is 9/5 C plus 32 equals F. And box that answer. They're not like terms, so I just write them next to each other. Remember, our variable term always comes first, and our constant, which is our number, comes second or last, okay? Let's solve the simple interest formula for P. So this one time I'm taking this simple interest, this I equals PRT. So I equals PRT, and they want us to solve for P. Well, what's happening to P? Multiplying. How do we undo multiplying? Division. What are we going to have to divide by? RT. Yay! RT cancels out on that right side. I'm left with interest divided by RT equals P. That's as best as I could do it because they're all different variables, so I can't combine them. Okay? They just stay next to each other and dividing each other. The last one, solve the area formula or area of a triangle formula. A equals 1/2 BH for H. Okay, Well, what's happening to my h here? Yeah, multiplied by b and by a half, right? So, do you want to get rid of the b first? We'll move that guy over. All right, let's divide by b. Okay, so I have a divided by b now equals 1/2 h. 1/2 is being multiplied by h, so we can get rid of it by, I could divide by half. What's another way to get rid of a fraction? Multiply by 2, yes, multiply by the reciprocal. Awesome, so either one, you're gonna get the same answer, okay? When we're multiplying fractions, remember the top multiply with each other. So 2 times a gives us 2a, and the bottoms multiply each other. 1 times b is still b. And so we have 2a divided by b equals our h. Okay? If you were dividing by a half, you would have had to do 1 divided by 0.5, and that would have gotten you your 2a as well. Okay? It just looks a little different. All right, next page. We actually did that before, okay? So we did all this work. I'm just going to use the work we already did. I'm going to use this formula here to change my Celsius to become Fahrenheit, okay? Simple interest, yeah. Okay, so we're going to use our simple interest one to the first page. Since we're talking distance and a speed and a time, we're going to use this distance formula. Can we agree that going from one point to the other and then returning, is that the same distance there and back? Yeah, okay, he just cruising right along. Read carefully and show all work. Mercury has a surface temperature of 427 degrees Celsius. Venus has a surface temperature of 864 degrees Fahrenheit, which has the greatest surface temperature. Okay, well, let's box or circle Mercury with their temp and Venus with their temp. Okay, are they the same units? No, if they were, we could just compare them, right? So I don't care which one we decide to convert. We have formulas for both. So do you guys want to convert the Celsius to Fahrenheit? Since that's what we do here. Yep, we read it in Fahrenheit. So let's do that, okay? So I'm going to flip back a page so you guys don't have to. So we have 9/5 C plus 32 equals F. I'm just copying the formula for now. So our C, remember, is this Celsius here, this 427. So I'm going to replace C with 427. So 9/5 times 427 plus 32 will be our Fahrenheit. So multiply first, before you add the 32, multiply your 9/5 by 427, and then add 32 to that. So I'm going to go, I ran out of space, so I'm going to write it here. 800.6 equals our Fahrenheit temperature. So now they're both in Fahrenheit. Which one is the greater temperature? Venus, yeah. So we write Venus has a greater surface temp. Okay, because they're at 864, which is bigger than 800.6. Number 5, you deposit $5,000 in an account that earns simple interest. Okay, underline deposit, 5,000, underline simple interest. Those are kind of context clues, key tools that we're going to use. After 6 months, the account earns, I got to erase, $162.50 in interest. Okay, let's underline 6 months and earns $162.50 in interest. And then they say, what is the annual interest rate? Okay, when you see simple interest, out of those formulas that we were looking at, which one are we going to use? And I'm going to scoot this over here. So we have our interest, our principal, our rate, and our time. Okay? I want to see what they give us, because they need to give us at least 3 of these in order for us to find one of them. Okay? So, do we know how much interest we made? That's what the I is. Do they tell us how much interest? And interest is money earned on your money that you put into the bank. Well, we deposited $5,000. Yes, where it says $162.50 in interest. That's our interest. So $sign $162.50. Good. Okay, right here. That's our I. Our principal amount is that $5,000 that we deposited. Very good. Okay, so $sign 5,000. And that was right in the beginning. You deposited $5,000. Now, our R was our annual interest rate. Well, that's part of our question. What is our annual interest rate? So that guy, we don't know. We're going to put a question mark. That's what we're looking to find. That's what our question is. And the last thing is the T, the time. Remember, I told you it had to be in years. So, yep, 0.5 years. 6 months is really 0.5 years. So we're going to have 0.5 there. Okay, so now that we have all of our pieces, let's use our formula, okay? So our formula states that the interest equals P times R times T, right? But the one I'm missing, the one I'm trying to find, what variable am I trying to find? What letter? R. So what I could do, so I don't have to do this later with numbers, that makes it more confusing, they're large numbers, okay? I can actually solve for R now. So what's happening with R on that side? Multiplication. So let's divide it by what two variables? P and T. So divide by P, divide by T. Okay, P's cancel, T's cancel. So I have this new formula of the interest divided by the principal times time will equal our R. This is what we're going to use to plug in. This way I don't have to do all that division with numbers. I did it with the variables instead. Now, could I still do it with the numbers? Absolutely. There's two ways to do this, okay? So I'm fine doing it this way first, and then we could do another way with number 6. So now we're going to plug in. Well, the interest we said was $162.50. That's our I, okay? Kind of color code. I, right? All of the blues. Then our principal was this 5,000. Okay, so we're going to put 5,000 down below there. 5,000. And we have to multiply it with the time, which is what? 0.5. Okay? We'll put that in pink. 0.5. And that's going to equal our rate, our R that we want. Okay? So make sure that are we going to divide first or multiply first here? Yeah, we got to multiply the bottom first before we divide that 162.50. Okay? So multiply the bottom. What do you get when you do 5,000 times 0.5? 2,500, 2,500. Good. Now take your 162.50 and divide that by 2,500. All right, so 0.065. Okay. Now I told you guys that the annual interest rate is usually given as a percent, but we got it as a decimal. How do I change a decimal to a percent? It is 6.5. What do we have to do to get it to be 6.5 mathematically? Multiply by how much? 100. There we go. Okay? So anytime you need to change to a percent, you're going to multiply by 100. Okay? And so we get an interest rate. So we could say the annual interest rate is 6.5%. Okay? And that was just taking our decimal and multiplying it by 100 to get our percentage for our interest rate. So, on this next one, let's do a different method. Same type of problem. They're asking this time, how much money must you deposit in a simple interest account to earn $500 in interest in 5 years at 4% annual interest? Okay, so I have my letters, right? My variable, I, P, R, T. My interest, my principal, my rate, my time. This time they're asking, how much money must you deposit? The deposit is my principal amount, so I don't know that amount. I do now know that we're working with simple interest. That's why we're using our variables in our formula here in a moment. We're going to earn $500 in interest. That's my capital I, $500. Okay? Next, they said in 5 years. Well, that's my time, and I don't have to change it because it's already in years for me. And my R, I saw it here, 4%. Okay? Now, you guys told me to change a percent to a decimal. What do we divide by? 100. Good. We need to change it to a decimal. So is it 0.4 or 0.04? Good. Okay? So we're going to use our interest equals P times R times T. We're not going to solve for our P this time. I told you we could just plug it into our original formula as well and solve from there. So that's the method we're going to do this time. Both will work. So let's plug in our I was 500, right? Equals, we don't know the P. Our R was 0.04. Our T was 5. On this right side, everything's being multiplied, so I can multiply 0.04 and 5 together. What do you get when you multiply those two together? Okay, so we have 500 equals P, times 0.2. All right. How do we get P by itself? Divide by what? 0.2. Let's divide 500 by 0.2. And what do we get there? 2,500. Okay? That's our principal amount. So I need to deposit $2,500 or $2,500. So again, both methods work. Whether you want to use the original and just plug in the numbers and then solve like a linear equation, you can. If you want to solve for the letter first and then plug in, you can do that too. Okay? Next one. A truck driver averages 60 miles per hour while delivering freight to a customer. On the return trip, the driver averages 50 miles per hour due to construction. The total driving time is 6 hours and 36 minutes. How long does each trip take? Okay, so we have the truck driver. Here's my beautiful drawing of a truck. Yay! And he's going 60 miles per hour, right? Going there to deliver freight. Okay, we'll say X marks the spot. And then on the return trip, so on the way back, he has to decrease his speed to 50 miles per hour because construction, okay? They said the total driving time. So they're saying the time there plus the return trip, so the time returning, equals how much total time? Okay, 6 hours, 36 minutes. Now, we talked about when we have different units of measurement. Can we have different units of measurement? No, we really need to convert it. Either convert it to a decimal or a fraction, but we need to change it a little bit, right? So how many minutes are in an hour? 60. So it's really like, if I were to write this as a fraction, it would be 36 over 60, right? Because 36 minutes out of 60. Is that a nice decimal? Can you guys check? 36 divided by 60? Yeah, 0.6? Okay, so are you guys okay with just writing it as 6.6 hours? Then we're in one unit of measurement, and we don't have to mess around with the minutes being separate, okay? And it's not really a large number either. All right, so do they tell us the exact time of each trip? Or no? No, they told us how fast we were going, right? But they didn't tell us a time. We just have a total time. So I'm going to flip back. Went slower going one way. So the distance is the same. So we can actually represent the distance because do I know the distance? No. So I'm going to keep it as D. Now our time, remember, D equals R times T. I'm going to kind of reference this so I don't have to flip back and forth. If I want to find my time here instead of my distance, how would I isolate my time so that it was T equaled something? Yeah, divided by R. Awesome. Divide by R, divide by R. So we have D over R equals T. We're going to use that guy because we have a D. We know their distance is the same, and we know their rate. And so if I don't know the time there, I can actually substitute it with the distance over the rate. So it's going to be D over, how fast were we going there? 60. So D over 60. Plus the time returning, we're going to represent it as distance over how fast were we going on the way back? 50. Okay. Whew. Now we have it set up. D over 60 plus D over 50 equals 6.6 hours. All right. What number is really up top with my D? 1. Okay. 1 over 60. That's not a pretty decimal, is it? All right, let's keep it as a fraction then. Are these like terms? Yeah, they both have D's. So can we add the fraction piece together? Let's add 160th plus 150th. And let's see what we get. It's not going to be a pretty decimal, so convert it to your fraction. 300, all right. 11 over 300 equals 6.6. All right, I'm multiplying 11 over 300 and D. So to undo that, I want to multiply by the reciprocal. What's that? Good, 300 over 11. 300 over 11. Okay, that cancels out my 11 over 300, so I'm left with just the distance. And then 6.6 times 300 over 11. Make sure you're able to get your 180 in there. Okay? To find the time, we're going to divide 180, which we found for our D, and divide it by how fast they were going. So take 180 and divide it by 60. Okay? So 180 divided by 60, whoop, and that gives us 3. So 3 hours there. Okay? Do the same thing, or think about it. If it took us 3 hours to get there, 3.6 hours back. Okay? If you divided 180 by 50, you'd get 3.6 as well. Okay? Because that was our total time. How many minutes is the 0.6 part? Bless you. 36, because we converted it earlier. So if you wanted to or needed to write it as hours and minutes, we could. All right, so there's our, how long did each way take? Well, it took 3 hours there, and it took 3 hours and 36 minutes on the return trip.